Magandang araw. Ako si Huey Code. Welcome back to my channel where I teach Python through fun and practical examples. So today, of course, we'll be continuing to dive into our software design patterns. We only got a few of them left. So this video is about the Memento pattern. So a Memento pattern is used to capture and restore an object state without exposing its eternal details. So in games, it's perfectly for features. It's perfect for features like undo, checkpoints, or saving and loading files. So instead of copying the whole object, we can just store the important parts like health or position so we can safely roll back previous states without breaking anything. So I'm just going to show you a trivial example at the very beginning, which doesn't work. And then, of course, we can just add the Memento pattern. That way you can kind of see the benefits about having it. So simply enough, we'll just have class. We'll make a player class. We'll have our init. Self, we'll have a name, HP, and I don't know, position. And then self.name equals name, self.hp equals hp, and then we'll have self.position equals position. Okay, and then we'll also have one for move, or a move simulation. We'll just have dx and dy. Self.position equals self.position. The position is basically going to be a tuple where it's just going to have the xy value, which is what we have this for. So there's position for x plus dx, which is the new location, and then self.position 1, which is the y position, plus dy. That's simple enough for our move function, and then take damage. We'll have self amount, and then we can do self.hp minus equals the amount of damage we took. Okay, and like I said, that's pretty simple. It's all we really need to show this I guess bad example that doesn't use a Memento pattern. So we'll have a player object. Let me just make it bigger. Player equals player. Let's call him hero. Will be the HP is 100, and the position is a tuple, which is 0, 0 for now. And then what we'll do is we'll save the state of the player. So let's say checkpoint equals player. And then we'll do player.move to 1, 1 from 0, 0. And then let's say when you move, you take damage. So we'll take 50 damage. And then we can print the player's HP. Player.hp. So just to show, we'll print the player's HP after taking the damage. Go ahead and do this. As you can see, the player has 50 health instead of 100 health. But what we'll do afterwards is player equals checkpoint. This is our saved checkpoint. And then we'll print it out again. Because remember, this was saved when the player had 100. And now we're printing it out after, overwriting it after the player has 50. So what should we expect? We would expect that to be 100. And it's still 50, and the reason being is because this is just a it's like a reference, so it copies the reference. So this player variable is pointing to the player object, and it's like I said, it's like a reference referring to the player object. So when we're doing this variable, you're copying the reference to this player object, which means this variable is also referring to the same player object. And because this player object health is now 50, then of course when we do this doesn't do anything because they're referring to the same object. And what we could even do is do it like this. Let's just say we'll just print player is checkpoint, and this is going to return true, which you can see what this means is that the player is the same as the checkpoint. But if we're to do this, we have a different object now. So of course, if we do that, this we would expect to return false. Because even though the values are the exact same, these are two different objects, whereas player and checkpoint is literally the same object in memory. So obviously this doesn't work. So what we're going to do instead is make a player memento. So class player memento init self HP position. This is the stuff we're going to save, and then self.hp equals HP and self dot position equals position. So this is what we're going to save. So the move is still fine to keep the same. And then this is still fine to keep the same. And then what we're going to do is add a function for loading and a function for saving. So def save state. And then what we're going to save is return a new player memento. And then you pass in the information you want to save. So self.hp and then self.position. And then we'll do the same thing for the load. Load state. And for loading, we pass in the memento. Self.player HP equals the memento HP, which is in the one that we saved, and then self.position equals memento.position. All right, so that's good. And now what we're going to do is, rather than doing this, we're going to, well, actually, let me just delete all of this first. I don't really need this either. And then the checkpoint will be equal to player.save state. We'll save the state, which is good. And then we'll just do player.move, the same thing we had before, 1-1, and then player.take damage. So take 50 damage. And then we'll print player.hp. And then after we show that we actually did take the damage, well, then we can just do player.load state. We'll pass in the memento, which is what we saved. And then that's going to, this memento is going to go into the player object, overwrite the existing data, and then it's going to revert back to 100. So of course we can just print player.hp, and then you'll see that this should show 100. So perfect. So first we had 50 damage, we have 50 health left, and after we loaded the state, now we have simply 100 health left, which is back up to full. So that's basically the memento pattern. It's pretty easy. You just save states, load states. Of course, you can imagine all the situations where you'd want to do that. So that's it for this video. Please like and subscribe if you found this helpful. Don't forget to hit the notification bell to be notified right away of any new videos. And always let me know in the comments if you have any questions or suggestions for future videos. See you next month, Kuya Code. Paalam.